All right, in this video, I'm going to be looking at finding products, quotients, powers, and roots of complex numbers. Okay, now complex numbers are numbers that include the real numbers. So like, don't forget the complex numbers include all the real numbers together with the imaginary ones. Okay, and so any number, any real number can be written in complex number form. Now, the thing is, finding the product, quotient, power, or root of a complex number is easy when they're written in polar form. This is easy when they're in polar form. I'm having trouble writing today. And I wanted just to show you that, okay? All right, so for the problems that you're going to be asked to do, they'll sometimes already be in polar form. The complex numbers themselves will be in polar form. If they're not, you could convert them into polar form and then use the what we're going to find in order to work out the product, quotient, power, or root of the number. All right, so here's an example. This is number 15 from the homework. Okay. So they give me one complex number that's in the form, in polar form already. It looks like this. And then I have another one that's 7 times cosine of pi over 12 plus I sine of pi over 12. Okay, so there's my two complex numbers, and they're asking me to get it written to find the product, to find ZW. Okay, now here's the result the notes are talking about. So by now you've hopefully read the notes and then can think about what to do. So basically, on these, you're going to wind up multiplying the moduli. That's the numbers out in front. So you're going to multiply those, and I'm going to show it. And then what you're going to do in here is add the arguments. Let me jot that down. So you're going to multiply the moduli, the moduluses, and then add the arguments, which are the angles. Okay, so you're going to multiply these and you're going to add these. Okay, so I need to take the pi over 11 and add the pi over 12 to it. All right, so when I do that, that's going to be 12 pi over, what is that, 132, 120, 120 and 12. Yeah, 132. And then plus 11 pi over 132. So that's going to be 23 pi over 132 plus I sine 23 pi over 132. And you're done. Okay. Well, almost done. I need to do 8 times 7 and say 56. And then you're done. That's all there is to it. So if you have a complex number that's written in polar form, then you can find the product of it by just multiplying the moduli and then adding the argument, adding the angles together. All right, so that's number 15. All right, number 16 has you do the quotient, which is a very similar result. And this one also is starting out with the complex numbers written in polar form, so I don't have all that work to do. It's expressed where the argument is in degrees. So there's one, here's the other one. Okay, and what you wind up doing if they ask you to find, this one's asking me to find the quotient, so Z1 divided by Z2. So if they want me to find Z1 divided by Z2, what I'm going to do is divide the moduli and subtract the arguments. So 12, it'll be 12 divided by 4, and then cosine 48 minus 8 degrees plus I sine 48 minus 8 degrees. So that's going to be 3 cosine 40 plus I sine 40. And I'm done as long as what they want, as long as they just want it to leave it in polar form. Okay. Now, I'm going to go ahead and do the powers, and I think I'll save the root for another video, but let me do powers of complex numbers because it's pretty much a similar result to what you might have expected. All right, when you're doing the powers, when you're doing powers and roots, okay, that's de Moivre's theorem. So he figured out this result, and it goes by his name. All right, so basically it's kind of like what you would expect from the product one. So if you had something like complex number 6 cosine 15 degrees plus I sine of 15 degrees, and that whole number, that whole entire thing is being raised to the third power. Okay. You can imagine that this would have been written, you could think of it as this being written 3 times because of the 3, and then you could apply what we did up here for products. So if you had that number written 3 times, and then you do what we did here, up here, we would just have multiplied the moduli, so it would multiply by itself 3 times, and then we would have added up those arguments 3 times. But the simpler result is that when you have that situation, okay, then you can just raise the moduli to the third power, but then take 3 times the argument. And again, it's very easy to think about if you just think about it being spread out and written. I need to throw the sign in there, written out 3 times. And you don't really have to remember anything new. It's just that times itself 3 times. Okay, I'll just put dot, dot, dot. Then can you see how you would do 6? If you use the result we did in problem number 15, you would just take 6 times 6 times 6. You would multiply the moduli. Well, 6 times 6 times 6 is 6 to the third. And then you would add the argument. So that'd be 15 plus 15 plus 15. And that's the same as 3 times 15. So 17 is basically just like 15. It's just you don't have to write it out so much. So you do 6 to the third power. I think that's 216. And then cosine of 45 degrees plus I sine of 45 degrees. Parentheses there. You don't necessarily need the parentheses on the argument, but they shouldn't count it wrong if you do that. Right, and then let's pay attention to how they want the answer. They say, find the indicated power, and then it says, write the answer in rectangular form. So this is the polar form, so I'm not done. They want it in rectangular form. So what I'm going to do to finish it is basically find the cosine of 45. I know that, square root of 2 over 2. Okay, sine of 45, square root of 2 over 2. And then I'm going to take that 216, okay, and distribute it. So I'm going to do 216 times square root of 2 over 2 plus 216 square root of 2 over 2 with an I on it. And so then this would be 108 square root of 2 plus 108 square root of 2 with an I. Okay, and so they wanted it in rectangular form, they said. So this is what you would type in for your answer on number 17. All right, and then let's do one more if I can on this video. I want to go ahead and look at what if it's not starting out in polar form. Okay, so let's look at number 18. All right, so with my number 18, yours might be a little bit different. You know, also, let me just comment on this. If they'll let you, I think you'll do a whole lot better if you sandwich the I in between there, so it doesn't wind up looking like this I is underneath the radical. So let's go ahead and sandwich it. I believe it lets you do that, and I think that's better. All right, and then number 18 from the homework. Get it in black. 18, this is from the homework. It just wants you to find this right here, 1 plus I squared of 3 raised to the third power. Okay. And you want your answer to be ultimately in rectangular form. So yes, you could do 1 plus I squared of 3, write it 3 times. You could FOIL. I need to get those I's in there. You could FOIL and then multiply through again, etc. So you could do that and see that it's going to be equivalent to what we get. But what we could also do is rewrite this and put it in polar form. So we could think about that 1 square root of 3. I like to picture it. So 1 square root of 3 would be like right here. And we could think about that as like the point 1 square root of 3. And we could figure out our r and our theta, okay? And so if we did that, the r is just going to be the square root of the 1 squared plus the square root of 3 squared. So that's going to be the square root of 1 plus 3, square root of 4, r is 2. So 2 is my r. And then I need this angle right here. All right, so to find that angle, I can use the fact that tan, and remember this is 1 and this is square root of 3, that the tangent of the angle would be the y coordinate over the x, which is square root of 3. All right, now at that point, I'm thinking to myself, hey, that's something I've recognized on the unit circle, and I can just see, oh, you know what? That's going to be equal to pi over 3. And let's see, I don't think it matters since we're the ones doing it. If we're more comfortable with degrees, we could do degrees. So theta has to be 60 degrees. Okay. Now you could do the tan inverse, but most of the time they want you to get exact answers with no rounding. So if it's something that you can get from the unit circle or a special right triangle, you should do that. Okay. So now that we know what r and theta are, we can go and write this in as a polar form of a complex number. So it'd be 2 cosine 60 plus I sine 60. Okay. All right, and then we want to take all of that and raise it to the third power, right? Okay, so now we're going to apply de Moivre's theorem. And it says, okay, you can raise the modulus to the third power, and then you can just multiply the argument by 3. So this will become 180 inside here. Okay. So we have 2 to the third is 8, and then this would be cosine of 180 plus I sine of 180. And then if they had wanted it in polar form, you would be done at that point, but they said they wanted it in rectangular form, right? The answer in rectangular form. So let me think about 180. That's here, right? So that would be negative 1, 0. So the cosine would be negative 1, and the sine is 0. So you wind up with negative 1. That's just going to be negative 8, isn't it? Okay. So your answer on that just turns out to be negative 8. It's like negative 8 plus 0i. Okay. So it turns out not to have an imaginary part when I'm finished. Okay. So that was problem number 18. All right, I'm going to go to a new video to do the roots because they take a little more work, and this video is getting kind of long.